Geometry day 2, worksheet 2, same thing as yesterday, just a little practice. If you know what you're doing, go ahead and do it. You don't have to watch this. I'll have the answers, just answers posted today. I forgot to do that yesterday. There will be something posted. Check it out. Make sure you're good getting them right. All right, for you who need help, I will start. I'll do the first one together, and each one will get a little bit less involved, and hopefully you take the reins from there. Okay, so let's see what we have. How many grams of iron 3 oxide will be produced from 300 grams of iron dichromate? Okay, so let's find what we have here. So we have 300 grams of iron dichromate. So let's write that above the balanced equation. Right up here it is. Let me get a pencil that actually writes. How about indigo today? Love the indigo. So we have, let me make that a little bit bigger. And when I start writing on top myself, you just let me know. So we have 300 grams of this, and we want to know how many grams of Fe2O3 there'll be. So how many grams of this? That's a good start like that, okay? That's the first thing you need to do. You need to be able to decipher the question and get to the point where you can figure out what you're going to do. Now remember, our pattern is grams to moles to moles to grams. So we have to follow that. That's each step. We start with our givens. All right, so we have given. These first two steps are the given. The last two steps are the unknown, right? And so I kind of color-coded that there in a weird kind of way, but we're going to go with that as the way I'm going to do with this one, okay? All right, so we're going to start with our given amounts. And you see just the top of my head on, I just disappear altogether. There we go. So here we go. All right. Always start off with your given. 300 grams FeCr2O7, right? Now we go to moles of the same material. It's always the same, FeCr2O7. And then we go to moles of the unknown, what we're trying to find, which in this case is Fe2O3. And then we go to grams of Fe2O3. You see that pattern? What you're given grams, given moles. When I say given, I mean that same label. And then we have what we don't know, what is unknown. It's the Fe2O3, moles of Fe2O3, grams of Fe2O3. You gotta follow that pattern. Before we put any numbers, let's do some crossing out. Let's put grams of FeCr2O7. Where am I getting that from? Well, I'll tell you where I'm getting that from. I'm taking this right here. I'm not taking the number. I'm just taking that label and I'm crossing it down, right? Because I know that I can change moles into grams. And then what do I do in the next step? I do the same thing. I take this label and I put it down here. Moles, FeCr2O7. Okay, now it changed over. I don't fret, I don't care. I'm doing the same thing I was doing before. I'm just moving whatever label I have down to the bottom shelf. All right, notice only 2 labels used the entire time. Right, the given and the unknown. For fun, let's just color this in too. There we go. Now it's super pretty. Okay, now here's where the numbers come from. We've got to have the numbers. And the numbers come from, first of all, this saying. If you have moles over grams or grams over moles, the moles is always 1. And the grams, the mass, comes from the periodic table. So here's where we drop down. We have Fe. Let me see here. Hey, there we go. So we have Fe. Oh, there it is. Looky. Fe is 56. Yesterday I added one of the weights up wrong, so I'm going to be extra careful today. Okay, so we have 56 plus Cr. And where's Cr? Chromium right here. Right? See it right there? 52. So plus 52. And there's two of them, so 52 times 2. Plus oxygen. And we all know oxygen's way over here, right? 16, right? And there are 7 oxygens. So 16 times 7 equals 272. So I'm going to write 272 right there. Okay. My next step is the mole-mole step. Let's go back to the problem here. Oops, I said something and I didn't even. So I wrote 272 right there. Okay, our next step is called the mole-mole step. I want to see you. I got to be able to see what you guys are doing. So if I'm up here, you can see my face, right? That means that I can see you too. There we go. So the mole-mole step. The mole-mole step is coming from the balanced equation, right? So that 2 goes with the Fe2O3. Did you see where I got that 2 at? It came from right here. Okay. Now, the FeCr2O7 has a 4 in front of it. See it right there? We put a 4 right there, right? The mole ratio comes from the balanced equation. Last step. We have moles over grams or grams over moles. The moles is 1. And the grams comes from the mass from the periodic table. So again, hello. We have Fe, which is right here, 56. And we have 2 of them, so 56 times 2. Okay. Plus oxygen right here, right? That's 16, and we have 3 of them. Fe2O3, so 16 times 3. And I've got 160 for that. Okay, and now where's my paper? I lost it. It should be here somewhere. Let's click on this and see what, there it is. So what happens? What did we just do? We just said 160 up here. Okay? Now, all we have to do is punch this into the calculator. Now, what I'm going to do is just say it out loud. I don't know what I'm going to do. I'm going to write it, how I'm going to put it into the calculator. You don't have to write this on your paper. 300 times 2, I'm going across the top, I guess, times 160, divide by 272, and here's the kicker, divide by 4. Now, I left the 1s out, but I got all the other numbers in there. That's how you want to put it in your calculator. That way you don't need to use parentheses or anything like that, and it'll work out just fine. So let me punch that in for real. 300 times 2 times 160 divided by 272 divided by 4. And I got 88.2. And so 88.2, and that'll be grams of Fe2O3. And I'm going to mark that maybe circled or square it. I guess I'm going to square it this time. Okay? And that's it. Right? Those are pretty. They're fun. I had a good time doing that. That was like super fun. All right? All right, now we're going to get less and less. I'm going to get less and less involved each time, and you're going to get more and more involved each time. Now I have room I can go. I can't quite reach above it. There we go. Okay. And what I did here is I tried to pick problems that were normal And I tried to find things that had different numbers in the balanced equation, so you'd have to take into account that mole ratio is what I was looking for here. All right, how many grams of Mn2O7, which is right here? So that's what we're looking for. How many grams of that? Let's go to a different color. Let's go to a purple color today. So we want to go grams of this, right? I guess I put question mark gram. It doesn't matter, as long as you know it's your unknown. And can be formed from 196 grams of KMnO4. So 196 goes up here. Okay, and that's what we got. That's once I write that down, I know that's all I need to know, right? That's all you need to know right there. Okay, so start off, remember it's grams to moles to grams every time. The first two are the givens. So we're going to start off with the number 196 grams of KMnO4 given to moles of the given KMnO4. Those are the given. That's what one came with the number. That's why it's the given, because the number was given to you. Okay, next one. All right. The last thing we're trying to find are the unknown. So the moles of the unknown, and it'll be Mn2O7. And then grams of Mn2O7. Okay? Right? Okay, now we need to know the masses. All right, so let's see if this works again. See, I just put the periodic table on my desktop, so that's what I'm doing here. Okay, the formulas were KMnO4 and KMnO7. So let's just find Mn, and we'll write that down. So Mn is right here. See it? Mn 55. All right, so I'm just going to jot this down to myself, okay? Mn equals 55. All right. K, I think it's 39. K is 39. See it right there? So K is 39. And then oxygen, I know that one's 16, right? And 16, it's right below me. 16. There we go. All right? So that's 16. So that's where I'm getting all these numbers. Okay, I just thought I'd write those down so you see what I have. All right? Now, let's see what happens here. We'll add them up. So I'm just going to write it right in the spot where it's supposed to be. Let me scroll up a little bit. So we have K, 39. I'll punch that in the calculator as we speak. Click, click, plus Mn, which is 55. Click, click, plus 16. Click, click, times 4. Click, enter, 158. So this is 158 grams. KMnO4. Okay. Oops, I guess I found that. Now, if we have that on the bottom, 1 mole goes on top. It looks like Mr. Arnold's changing up and doing it in a different format this time. Same idea. I'm just filling the blanks in a little bit different. Okay, let's cross out our moles of KMnO4, right? Now, mole-mole ratio. Mole-mole ratio has to come from the balanced equation. It's right there. So we just have to match things up. The Mn2O7 doesn't have a number. Well, that's a 1. What happened there? Eek. Oh, I disappeared. I just crashed it. Hold on. La, 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 la. So how is your day going? Oh, we're back. Okay, so look what happened here. Yeah, so this first one was a 1. And then the MNKO, or the KMNO4 has a 2 in front of it. Okay, I'm getting this from the balanced equation. You see that? That's important that you understand that part. That's the only new thing of the whole chapter, is look at the balanced equation and put it in that spot. Let's cross out these moles. Moles of Mn2O7. 1 mole, and then the mass will be 55. Oops, I'm in your way. Will be 55 times 2 plus 16 times 7. Okay, school's out, guys. I'll see you later. Is 222. Whew, that's a biggie. All right, that's the numbers I'm getting. Okay, now let's do this. 196 divided by 158 divided by 2 times 222. All right? This time I put the bottoms on first. It doesn't matter what order you put these in your calculator. The only thing that matters is that if it's on the top, you have a multiply in front of it. If it's on the bottom, you divide before it. You just keep dividing each time it's on the bottom, okay? I know you can see that. If you can't see it, hold a mirror up to it and you'll be able to tell what it says, okay? So that's what you do. I always put the given in first, and then it's pretty easy to punch them in like that. All right, this whole reason we use the table. And I might as well push enter too. And then I got 138, I'm rounding. Oops. And I'm writing with a highlighter. And now I'm writing with a text box. There we go, 130. It's 137.67 or 69, but we're going to say 138, right? You guys are okay with that, aren't you? If you're not, write down everything on your calculator. Okay. That was nice. Okay. Now, let's see what happens here. All right, there's 3 more to go. So, 165 grams of sodium hydroxide. That's our given. Na3AlO3, that's our unknown. It says how much, but we're trying to find grams, right? So we're finding grams. Okay, so let's do a little bit of reconnaissance for you guys. The given's going to go here. The unknown's going to go here, right? Pattern. Grams, moles, moles, grams. Formulas, right? Sodium hydroxide. I hope you did not forget that NaOH is sodium hydroxide, right? That's our given. You know, sometimes you gotta squeeze it in. Unknown, Na3AlO3. You know what, if I can't get the fit in that spot, I just put it above it. Now, I always say, make sure you use the right formula when you're writing this down, because what happens when people try to abbreviate the formulas, I don't know why you would do that. It's just a subscript or something you're leaving out. It's not that big of a deal. But when you do that, you always mess up on the masses. You always do. Okay, so now we have to cross out, right? So whatever I have here goes down here. Oops, let's try that a different way. Copy, paste. Ooh, I can shrink it down, right? Copy, paste. You see? I don't have to think. I mean, I guess if copying and pasting is thinking, which I think some of you guys sometimes think is, Yeah, I'm thinking really hard. All I have to do is move things down, right? Move them down. I'm going to erase those highlights off of there because I don't think I need them. Okay? So everything's set up. I'll tell you what. It's almost Christmas. 165. I'll write that in there for you too. That's the given number, right? Everything's set up. Fill in your numbers. Next one. Given. Unknown. And we're finding grams again. We're finding grams. So 81.00. Why don't we just call that 81 on your paper? If you didn't know, water's H2O, not HO2. And then how much BaO? So grams of BaO. Moles, H2O, grams, BaO. Okay? Next one. I know I didn't do much on that one, but I told you I was going to do less and less. And the last one, I'm going to leave it all up to you from scratch. Let's see what happens if I do this. Hey, there we go. So, you know what? It's not too bad. They're not that hard. Try them out. I will finish these up. The bell rang. It's like 3 o'clock. I'm going home. But tonight, I'll come back and I'll finish these up and I'll throw a key in there and then you'll have that tomorrow. Maybe I'll put the key in tomorrow morning, right? I'll throw that key in there. Not the work, just the number so you can check. Okay? And that's all I have to say. I probably talked too long already, so we'll stop it right there. Hey, have a wonderful day. Bye.